Well, good morning, good afternoon, ladies and gentlemen, and welcome to this online session where we discuss artificial intelligence, or also known as AI, how AI is reshaping the way that we work in the PV industry through smart inverters. And we have with us today three speakers, expert in the topic, who are going to actually give their know-how to everyone in the audience today so that you can understand this topic a little bit better. And I'd like to welcome them all and ask them to introduce themselves so that you can get to know them a little better if you don't already. So first, I'd like to ask Leandro, please, can you unmute your mic and introduce yourself?
Yeah. Good afternoon. First of all, thank you very much for this invitation. My name is Leandro Bento. I'm the SVP of Operations for Yellow Door. I'm a Portuguese. The last 16 years working on the PV, 12 of it on EPC background, and the last 4 on IPP. So I truly believe that artificial intelligence is here to improve our results.
Excellent. You can give us many, many points of view, Leandro. Where are you joining from today?
I'm in Dubai.
In Dubai. Excellent. Yeah. Next, I'd like to ask Jad to please introduce yourself.
Hi, everyone. Thanks for joining. I'm coming to you from Jubilee Bros Solar. We're a solar equipment supplier in the Middle East and Africa. We have a very big footprint throughout the Middle East and Africa, and I'm looking forward to hearing your questions and talking to you about the solutions that we're supplying through Huawei for AI.
And where are you, Jad, today?
Actually, I'm stuck in Australia since March.
So it must be a nice time in there. Like, it's probably quite late already. Thank you very much for joining us. Okay, last but most certainly not least, Rizwan, please, could you introduce yourself?
Thank you. So yes, my name is Rizwan. I'm the CTO for Middle East and Africa region. I'm being with Huawei now, situated in the Dubai team since 2018. So there's substantial growth available for the Middle East region, and specifically with the technologies and trends in the inverter industry. I'd like to open that up and share some insight in that today.
Excellent. Thank you very much, Rizwan. You said you're in Dubai. We can see you behind us if you were a TV presenter, you know, right with the skyline of Dubai. So as you can see, I'm joining from Spain. We have people from Australia, Abu Dhabi, Dubai, and we have a lot of attendees from many different places. Abu Dhabi, of course, Zambia. I've got people from Lebanon, Saudi Arabia, Ethiopia, Pakistan, Ireland, Lebanon, Pakistan, Germany, South Africa, Tunisia. So welcome, everyone. It's always great to see that there is such geographical interest, and this is why we think, you know, the webinars are such a great tool to spread information. So I'd like to ask the first speaker for today to please get ready, Leandro. Share your screen, unmute your microphone, and whilst Leandro is preparing, just a few housekeeping things for you in the audience. Most of you probably have attended our webinars before, but just in case you're new, essentially what we're going to do is we're going to have 3 presentations, and right after the presentations, we'll take questions. We have budgeted about 10 minutes for questions. So please send your questions through the Q&A box at the bottom. That allows us to manage them better than if you send them through the chat. They kind of get lost in the chatter. So please send them through the Q&A box and we'll try and get to them. And also our speakers usually respond them by text as well, even earlier than that. So please do that. And also know we are recording this session, okay? So you will have the ability to be able to watch it again, and we also will send you the materials so that you can check them up. We usually send an email within a few days of the event where we send you a link, and if you follow the link, you can download everything, okay? So without further ado, Leandro, the floor is yours. Thank you.
Thank you, Belén. So welcome to my presentation. As I knew that my colleagues, panelists would speak a lot about inverters on this topic, I prefer to give a wider vision on the artificial intelligence, data analytics on the entire value chain where we act, just to give you a better understanding of the potentiality of this tool. So the agenda will be brief. I will make a brief presentation about Yellow Dot Energy. Then I will run through that analytics, its importance, and then the artificial intelligence applied to the solar, not only on the inverters, as we will hear for sure on the following presentations, but on the entire value chain. And then some case studies that I will share with you. So Yellow Dot Energy is a company founded in 2015 in UAE and in Jordan. And this year we opened 2 new markets, Saudi and Bahrain. We have until now 110 plus megawatts in our portfolio. I would say 80% of that under operations until the end of this year. Yellow Dot is a company who provides a wide range of energy services, starting on the solar, going through the energy efficiency, hybrid systems, energy storage solutions. So we are not just a solar developer or a solar provider. We want to be seen as a full energy service provider. We build, we own, and we operate our systems, and we provide all these great solutions with clean energy at a cheaper price to our customers. Moving on. Okay, we count, of course, with our important shareholders that support our growth and expansion plans for the future, which is really important. And then I would start giving a bit of background on the value chain of our business. We cannot start without saying that the data is something really important to the improvement. So we need to check each step of our value chain and know exactly what are the critical points that we need to assess, and then try to get as much as data we can to then work it, analyze it, and improve. So we can start with development. On development, we basically run simulations over simulations to build our financial model, to know exactly what we can provide to our customers, what kind of savings, what kind of benefits we can give to our customers. And we need to know 3 key things in this process. We need to know how much we pay, what is the cost. We need to know when we pay, so the cash flow, because that will impact on the internal rate of return of the project, and how much are we generating, because that will be the revenue. These are the 3 key and critical points on the development. Then on the construction, we have a well-defined timeline, budget, scope of works, technical and health and safety requirements, specifications, and the target of the project managers is to make sure they can build the plant under the budget inside the timeline. On the operations is the last part, but one of the most important, and the target is to get the best of the assets, maximum performance, to have the plant with the maximum availability to take the best of it, improve the efficiency of the project on a continuous basis, and analyze and adjust maintenance plans, for example, to make sure we are doing the best we can for the asset. And since the very beginning, I learned if you want to improve, you need to measure, right? And you need to measure, and you need to learn with the experience. And we have 3 steps here in the value chain that can give a lot of information for the initial ones. So if we go, for example, to the construction can bring feedbacks about the costs, about timelines, about the obstacles they faced during the construction and that were not expected during the development phase, optimizations we can do on the assets, and this is all information, really important information to seek the results we want. Improve the accuracy on cost estimation, project timelines, and cash flow. So these will drive to a better simulation, as we said before on the development of those three key points we mentioned. So the more we get, the more experience we get, the most accurate we will be. And for example, on the operation, we can give some feedback to the construction. Imagine that the O&M manager can, for example, talk with the project manager or with the development on the technical side, saying, hey guys, I need at least 3 or 4 meters between rows because I need to have a truck going there to clean the modules. Okay, in this project, we don't have that size, so we had to adapt the cleaning. So these are all experience we bring from the project, from the reality to the development. And on the same side, on the operation, we can adjust the performance. We can check the equipment reliability. If we have equipment that is always failing, creating a lot of outages, we can flag that to the development team, to the technical team, saying, please stop using this equipment because we are getting a lot of unavailability due to this. We can check, for example, if the annual degradation that our PV modules suppliers mention on the guarantees are exactly the ones that we see on the data, on the real data. And if it's not, if they are conservative, we can be more aggressive on that. Meteorological conditions as well, we can offset the meteorological data sets with the reality we are getting. Of course, we can adjust a little every year to go to the most accurate figures we can. And as a result of this feedback from the operation to the development, we have the improvement of accuracy on project simulation on the PVCs as you want. This will lead us to a much more accurate revenue calculation, and for sure we will improve the project reliability with efficient equipment selection. All this is the return of the data collection we do every day with the construction teams, with the operations team, that allow us to improve the development and to be more and more aggressive. And then we come to a topic that is always in our minds. Everyone is discussing this on a daily basis, competitiveness of the business. But when we talk about being competitive, we always assume cost as the only aspect to be competitive. But there is any other point where we can look? Yes, sure. What about the revenue, the energy expectations? This is the other side of the scale. So we don't need to look just for the cost. Of course, we need to do our hard work to bring the cost down. But if we look to the other side of the scale, we have on the revenues, on the energy production, possibility to improve our price and cost competitiveness of the solution. And how can we do this? We get the data, we get more accurate simulation, we get more comfortable, because if we have more accurate simulations, we are more comfortable with the numbers. So if we are more comfortable with the numbers, we don't need to have so many safety buffers. We can reduce it, we can cut it, and then we will get higher energy estimation. So imagine to a limit of getting with the same cost, more energy. So we are reducing the the cost of the tariff, and this is making us being more competitive. And this is a cycle that never ends. So we will again get data again. We'll analyze the data, run more simulations, get even more accurate, being more comfortable, and the process will continue in this way. So this is how we can be more competitive using the importance of the data. And then we have on the operations of the project, we have the other side. For us, a key stakeholder of this process, the asset manager. The asset manager is taking care about projects, performance, and profitability. Right, is his main responsibility. But what is the meaning of this? Is he just monitoring the plants to see if we are above the guaranteed values that we promise to our clients? I would say not at all. It's much more than that. I look to a PV plant first as not a static thing that is there, that was planned, and it will be always the same. No, I look to a PV plant as a dynamic, as a live part, and for sure, the asset manager to be a great asset manager needs to be like a coach, like a football coach. He knows exactly what are the behavior of their players, how they feel. They know it inside out. They know what are the weaknesses. They know what are the strong aspects of the asset, and we can translate this as well to the PV. If we know the PV system or the asset inside out, if we know how it behaves, if we know how it feels, for example, under some different conditions, we can get the maximum of it. Okay, we can revamp it, we can optimize, we can, for example, adjust the maintenance plan, reducing downtime, using the lower irradiance hours to do the maintenance, increasing the availability. We can, if we know the asset, we can predict potential problems that happened in the past and that might happen again if we are under the same conditions. And then we can analyze the meteorological data sets and reset the data sets for reference. Nothing of this will be possible if we don't collect data and if we don't work with the data we collect. And then you can ask me, okay, but we came here to speak about artificial intelligence. Yes, it's true, but the base of the artificial intelligence is the data, right? If we don't have data enough to run the algorithms, we cannot evolve. So we can do, I would say, we can do probably 80% manually. All these analysis that I was speaking about, we can do it manually. We don't need artificial intelligence. But if we want to be on the 100% or that extra mile, for sure we need to have artificial intelligence applied to our business. We can do it manually. However, it will take a lot of time. It will take a lot of resources. And if we use the artificial intelligence, it can do it. It can do it for us in a more efficient way with less resources, with less time. I used to say that the artificial intelligence is the same of a team of 10, 20 people inside a room with supercomputers that can do the work we are doing with our people manually in a much efficient and much better way. Okay, some examples of AI applications. For example, triggering the cleanings based on factors like soil levels, meteorological conditions, cost, past experience, identify potential problems that had occurred in the past based on internal or external conditions, temperature, or load on the system, or condition of the equipment. We can predict that we might have a problem with that conditions because we had the same problem some years ago. We can define much better the maintenance plans, cleaning plans, the bigger maintenance that we incur in a more curtailment or a bigger outage. We can plan accordingly to save the energy or to reduce the impact on the energy. We can offset the meteorological data set and getting more accurate. And then we can use the artificial intelligence to help us to forecast the energy production on an intraday, daily, weekly, whatever we need. I can tell you that we are using the manual kind of intelligence. Yet we are preparing to put in place some algorithms of artificial intelligence, but these are the results we are getting with the manual. So imagine what we can get if we start working with artificial intelligence, and if we set up that 10-20 people group with supercomputers, meaning that we start using the artificial intelligence. When we use artificial intelligence, we change or we replace these 10-20 people with supercomputers for a couple of computers, and we can run the process much faster, much accurate, and in a fantastic way. Sorry, I'm going back. Okay. In summary, because I think I have taken some time already. I would say the data analytics and the artificial intelligence will allow us to get better and more accurate performance guarantees for our clients. It's really important to get the maximum of the asset, generating more clean and cheap energy to our customers. We add on top of the monitoring of our O&Ms, we add a second layer of monitoring, so we can put some pressure on the O&M, saying that we are not as good as we would like to. So it's fantastic, and we can increase the efficiency of our assets, and with that we can increase the competitiveness of the asset itself. I hope I have helped with this presentation to understand that the data analytics is fundamental to the improvement. That analytics applied by artificial intelligence is fantastic, because it allows us to save a lot of resources, a lot of time, giving us the instructions we need to improve. And it's the future, for sure. It's not just a buzzword, it's the future.
Thank you very much, Leandro. It's the future. This is what I'm definitely taking away from this. If you could please stop sharing the screen. And yep. Good news, we still have we already have a couple of questions for you. I'm sure they're not going to be the last ones that we receive. So please don't be shy, send your questions, use the Q&A box. Leandro is going to take a look now and perhaps even start responding them. Next, I'd like to ask Jad to please share your screen as well and unmute your microphone. That I might be able to do. There you go, yes. And as you saw in Leandro's presentation, at the very end, there was an email address that you can write to him in. It's the same with all of the speakers. They'll have details if you need to contact or if there is anything like that, okay? Remember that we are recording this session and that you will have access to the recordings and also to the materials that you're seeing on screen. Jad, go for it. Go ahead.
I'd like to say that AI is the future, but it's also the present. Huawei are already using AI to reshape the PV industry, and they've been doing it for quite a few years, I would say. And so I'll be discussing, three of the areas where they're using AI with some great effect. So Jubilee Brothers Solar is a distributor of solar equipment. We're a value-added partner for Huawei and a certified service partner for them. Jubilee Brothers is a Lebanese-based company. We are in 10 countries. We have 1,350 employees in power generation. We started our solar division in 2017 as part of this converting into renewable energy. And we currently have team members from our solar team in many of these countries that we're in. We also supply to distributors throughout the Middle East and Africa. We've built our solar division on these 6 pillars. We supply equipment, we provide training on design, installation, commissioning, and O&M. We also provide engineering support to help reduce LCOE, help also see how we can reduce the equipment needed for the system. With our extensive network, we can provide leads. We provide leads to our EPC customers and developers. We have access to finance companies that support us that we also refer to. And most important for me is the after-sales support. And I think this is probably something that Huawei AI is really shining for Huawei for O&M and after-sales support. I mentioned we're partners with Huawei. We are a value-added partner and a service provider for them. So what can Huawei bring? What does it bring? What do they bring with their AI? So efficiency, so reduced costs in power generation and improved O&M, accuracy, speed for analyzing the system, reduce the cost of labor, and increased yield. And I'm going to speak specifically about these 3 technologies that Huawei have brought out, which are using AI. Multiple MPPT, I think everyone's familiar with that. Huawei pioneered string inverters quite a few years ago now. And since then, they've been the #1 supplier of inverters worldwide, using string inverters for utility scale projects. I think this is married very well with AI, not just on the MPPT technology, but all the other technologies that come up with it. So fire protection, arc fault protection, and IV curve diagnostics. I would say that the MPPT and fire and arc fault protections are passive technologies that are used with inverters, while IV curve diagnostics are something active. End users, developers need to actually use this technology to make sure that they're benefiting from it. So smart MPPT tracking algorithms are allowing for Huawei to reach 99.9% efficiency, static efficiency, and dynamic efficiency of 99.69. These are TÜV certified numbers. When we talk about arc protections, and as well as with MPPT, there is a lot of they're using a lot of data and information from all the inverters that they've installed worldwide, and with the data they're using self-learning and AI with AI to provide accurate detection for arcs and provide speedy shutdown for the system whenever an arc is detected, less than 2.5 seconds. And you know, for asset managers, this is really important because this also means you're protecting your asset, not just the solar system, but also the roof that it's on, the building that it's on as well. So my favorite technology, I would say, is the IV curve diagnostics. So Huawei, it uses a IV curve diagnostics is based on string IV curve pattern analysis. And basically, by analyzing plants from all over the world, you know, Huawei already has installed 130 gigawatts of solar system worldwide. This information, their inverters are smart, connected. That information is being uploaded, and they are, you know, AI is learning to understand what are the faults that are happening based on the IV curve analysis, and based on this, they can detect whether from the IV curve analysis they can detect whether your system is having for example, here, dirt cover, high string resistance, glass breakage, cracks, and there's in total there's 14 different string failures, which are in fact also TÜV certified. And this technology now is applied on 5 gigawatts of Huawei's, you know, newer inverters, meaning for example, in 15 minutes, an asset manager can have 100 megawatts analyzed and faults identified and recommendations given for action that is really important. Now, this technology is not only available on utility scale project, but residential inverters have this same technology. So, you know, anybody who has a solar system can use this technology. And this is why I say it needs to be used actively. So I'm sure Leandro will be using this technology in the future, and he'll find it very useful. And this is an example of what it would look like on a computer when you did that, when you do the analysis. And here's an example of our own rooftop in Jebel Ali, where we have 20 strings. Out of the 20 strings, we have 2 strings that are faulty. And you can see it actually tells you the reason, the most probable reason for that. And I would like to point out that, you know, even though we are a value-added partner for Huawei, I can say that our engineers prioritize other activities and don't do this diagnostics enough to really pick up all the faults. So even us as a value-added partner for Huawei need to be finding ways to use this technology. And here's a suggestion for these. So I mentioned there's 2 strings with some faults. Huawei's system also gives you recommendation on what steps to take. So you can send this to your technician on site and for him to take action on the particular string. This technology so now this is technology string-based, but Huawei also have micro inverters that will allow it to be panel by panel. So you'll be able to do this by panel as well. And I'd like to just conclude by saying the passive technology I mentioned, which is the arc fault protection and MPPT, gives you peace of mind. You're buying an inverter that already has this technology. IV curve diagnostics is an underutilized solution. I know Leandro, we were talking about this, and they need, you know, Yellador need and will be using it, and I'm sure they'll use it. But you know, my concern is how many other EPCs and users have Huawei inverters and are not utilizing this solution. You know, every fault is an equivalent of money being lost. So Jubilee Brothers really, we are, really, when I said after sales is the most important for us, we need to be part of the solution. How do we make sure that this technology is utilized? Because it's creating a lot of value, a lot of faults solved means a lot more power produced. And AI is helping to make solar the #1 choice for power generation in our regions. And the proof of that is, the lowest cost of electricity that's been coming out from the Middle East have all, been using Huawei. And I'm sure this technology has a big part in that. Thank you.
Thank you very much, Jad. Very clear, very to the point, and it's the present, right, as well.
Yeah, it's a present.
Let's stick to that. All right, so could you please take your screen off, and we're gonna go into the last presentation for today, which is Rizwan. If you please can share your screen and prepare, and questions abound. We have more than 4 open. Some of them are also directly for you, Jad. So feel free to take a look. Start replying some, and then as soon as Rizwan's done, then we'll take it live. So go ahead, Rizwan.
Thank you, and I hope you can all see my screen nice and clear. And
Yes,
thank you all
we
once
can.
again for attending. Great, perfect. So today I'm going to be talking in, let's say, an overall perspective, and one of those topics is AI. And we'll be looking from a perspective of trends in the industry, and specifically what the industry of the PV will look like in year 2025. So before stepping towards that stage of the level of what the industry will look like, we need to look at reputable ways of sourcing that relevant data. So whether that's speaking with vendors such as the panel manufacturers, or speaking with consultants in the industry, looking at the large organizations and what's happening on to the front of EPCs, developers, which module supplies are available. All of that, let's say, data is being fed through to basically our modeling and analysis center. So we've then analyzed that data and looked at what are the 10 trends. And in the next slide, as you can see here, these are the 10 top trends that we're seeing, which are going to become more and more important and embedded into regulations, which I will mention in the active arc safety topic. So without any further delay, I'll go through the first one, which is digitalization. So from the perspective of the plant devices and the digital technologies that is available, what we aim is around 90% of the global PV plants will be fully digitalized by year 2025. So that encounters devices to be understanding how they are reacting, how they are connected, if there's communication methods rather than which are robust enough to continuously operate, energy storage in order to support the grid at times as well. Transformer sensors need to also have an impact to, for example, solar inverters. So all of this digital era is coming, and this is coming from cloud-based monitoring. There will be a branch over to 5G as well, and machine learning, as well as understanding how to be intelligent. The second, which is the key discussion today, which is AI-driven upgrades. And specifically, we see that by around 2025, 70% of the PV plants will be adopted to AI. So how does that happen? Basically, algorithms. So before providing topics such as my colleague Jad mentioned in regards to IV curve diagnostic, that requires a mass worth of data, and that data needs to continuously adapt by the chipsets that are installed inside of the inverters. So when we provide, for example, a firmware upgrade, it adopts anything which the inverter is understanding and learning from the string performance, and adopting it to the firmware that we're providing on a let's say a changeover of a product. And when it comes to fault diagnostic, if the inverters are to fail or devices are failing on site, how is that proactively being identified? What is the root cause, and how can it be prevented going forward through the alarms and algorithms? And one of the other things which we see is the synchronization of solar and storage being interacted as one generation plant. So when we talk about data and the analytics, each year a 1 gigawatt PV plant generates around 1,000 gigabytes of data on average. So you can just see that it's not just a simple process of adding devices, it's about that communication channel back and understanding and putting it through a system which is clearly identifying the root cause. Trend number 3, which is unmanned PV plants. As we've recently gone through a scenario of a lockdown in multiple different countries globally, access to renewable plants has been limited. And we've just gone through a learning exercise on how to operate these sites without the manpower on site. So we need to be looking at unmanned drones. So for example, site inspections, or for the security of the site itself. So there needs to be machine vision recognition for security. Anybody that's operating close to the site, or the camera systems, it needs to understand that. And in terms of cleaning, the PV modules will require to be cleaned, especially in the Middle East region specifically, and that routine cleaning will require to be more robotic than on the manual form with the large sites that are being constructed in the Middle East as we speak. One other topic in terms of the proactive support from the power grids. So in the past, the PV plants have been able to generate and be connected, but in the future, what we are seeing is specifically, rather than being grid connected, they need to be grid supporting. So that's something in the next 5 years, things will be impacted in the SCR value, which is a short circuit ratio. And we've learned this from other industries, such as in the UK, there's been a blackout. And then in Australia as well, with the PV penetration actually increasing to double digit values, that requires the adaptation of storage to be adopted, or products to be switched off rather than be still connected. And at the end of the day, if your PV plant is switching off, it's losing revenue. And as I just recently mentioned, solar plus storage. So specifically, the proportion of PV systems with the energy storage is projected to exceed 30%. And that's driven by the cost of the devices, such as battery technologies coming down, well as the synchronization of using the battery in 2 different methods, when to provide a more stable, fluent power performance to the grid, or to offload and provide the power based on the energy trends at that particular time. So where there's peak times and off-peak times, that can be supporting those scenarios. VPP, which is virtual power plants. This is something which we are seeing already being developed in other markets, such as in Germany. Power dispatch and power transaction will be included within that VPP model. And it really requires the adaptation of monitoring the PV plants to a more accurate level, having a predictive generation based on local cloud platforms, and all of the systems providing a synchronized amount of data in the same format to a single port. So by 2025, around 80% of the residential PV systems will be connected to a VPP network globally. And coming into the industry of active safety, as my colleague Jad mentioned earlier, safety aspect is with the regulations. So we've incorporated a function called AFCI. You can see it on the short video on the right hand side. The spark, which is typically happening with a DC system, can be continuous, and that temperature gets very extreme, causing devices to catch on fire and spread. So with Huawei, we've incorporated an AFCI function, so arc fault circuit interrupter. So as soon as that, let's say, noise is detected within the circuit, the inverter will automatically, within 0.5 seconds on a residential application, switch off the circuit on the DC side. So, eliminating the risk of that fire continuing, and that requires the algorithms and the chipsets within our latest inverters. So in terms of trend number 8, higher power density, I'm sure that a lot of you guys today listening are probably seeing a transition of devices. So if you looked several years ago, you were using 600 volts DC systems. We adopted to 1,000 volt. And as of in 2017, the first PV plants with, let's say, 1,500 volt technology were being installed. And that's something which brings the power density of devices. So the power to weight ratio of PV modules, the same with the inverter. If you looked in 2012, a centralized inverter was banked up with a 200 kilowatt inverter in chunks of 5. And if you look at a string inverter in the industry now, you're having a string inverter weighing no more than 85 kilograms and powering around 200 kilowatts. So that's something that we really see increasing year on year. By 2025, solar inverter power density will be improved by over 50%. Modular design. One of the things that we tend to speak with our customers about specifically is trends in the industry. And if you look at data from IHS in the last 5 years, the comparison between centralized and string inverters has been shifted towards a string inverter solution. So this is seeing not only Huawei that is only providing a string inverter solution, but our competitors also following towards a string concept within their portfolio of products. So solar inverters, PCS, transformers, and energy storage all need to incorporate that same modular design so it can be easily adapted and more flexible to deploy on this rapid growing industry. And lastly, in trend number 10, would like to talk about security and trustworthiness. And specifically, as these plants are becoming larger and more important for the to the grid, specifically in the Middle East, where plants are above 1 gigawatt in size or being developed in the regions, they require to have a level of security which can not be extracted from any let's say bugs in the system. So by 2025, systems will be reliability, availability, security, safety, and resilience to the privacy will become more essential requirements. And at this day and age, I see some of the larger customers and developers that are in the industry already incorporating this, and others which are in, let's say, the residential application are not really seeing it as a important factor. But I do see that this will come down the chain further as these systems get, let's say, more into the VPP model. So thank you all for listening today, and I hand it back over to my colleague.
Thank you very much, Rizwan. Okay, so I think we've gone through the 3 presentations now. We've seen different aspects of AI, and there is a few questions still there to be answered. We don't have a lot of time. We have about 9 minutes. So the first question I want to ask is one that has actually come through the YouTube channel. That is very simple, and I think it should be quick to answer, and is what AI environment are you using? So if you guys want to, Jad, you want to start, and then we can ask Leandro, give Rizwan, a little break.
AI environment? Sorry, I'm...
Yeah, you go ahead. What AI environment are you using?
I'm not sure what he's referring to there.
Oh, maybe Rizwan knows then. Honestly, I saw, I'm not technologist.
Yeah,
so.
I'm happy to answer that if that's okay. So in terms of AI, it's really specific about the chipsets. So that's something that is incorporated within our latest, let's say, generation 4, generation 6 inverters, and those require, let's say, self-learning mechanisms to basically extract the data, but also provide feedback in a response which, for the interface, the customer is able to adapt to.
You guys, this is for the three of you. How much of this is really AI and how much of this is really machine learning? You know, like what, like you said, the difference between those two things. Are we seeing a true AI already, or are we seeing machine learning at the moment? Don't know who wants to take it. Leandro, go ahead.
I think you cannot split both, right? You cannot split or disconnect machine learning of the artificial intelligence, right? It's one works based on machine learning, to learning of with the data, with the past data, improving process, giving different kind of improvement actions. So I would say, but correct me if I'm wrong, Rizan. I would say you cannot simply disconnect both.
That's right, yeah. So from our side, it needs to be continuous learning, and that data needs to come from, let's say, proven track records of projects, whilst also adapting to the products and the features within the products themselves, making sure that they are taking that necessary data from site. And where is that data going? Is it being stored? Is it being monitored continuously? So it's a joint venture between both.
Okay. I have one for Jad here from the screen. This is regarding AI algorithm for PV. What input training data are you using from the PV4 curve, 1, 5 radiance temperature? And could you give a slight insight into the aspect of AI you deploy for this data? And I'm sorry, like these are so technical. So for me, I just have to read them and hope that you guys understand them. It's a question from Uttam Oyebanji.
You know, this is also a question for Huawei, and really we are helping getting this technology into the hands of consumers, but we're not developing it. Huawei are the ones that are developing it.
So yeah, I'm happy to take that one as well, no problem. So typically it's a voltage and current curve. The PV module suppliers provide a standard IV curve value and results for their particular PV modules. And physically what we're doing is we've regulated what is the minimum radiation values required on a typical PV plant, which is around 500 watts a meter squared. And once that is typically available, you can run an accurate IV curve from the monitoring platform. It will switch off the PV plant for a matter of seconds. And then the IV curve results will come back, go through an algorithm, and within 5 minutes for a residential application, you'll get a report back clearly stating what's happened, at what timestamp, and exactly what can be advised, if anything, on how healthy your PV plant is. So it's a very clear and precise, and typically what's being done at the moment is using manual labor. So either on a residential application, this is not done, or if it is done, it's done once per year with high-end machinery and the labor which is required. So this is something which can be done remotely, less labor, and more frequently.
Okay, so I'm just going to throw questions out there, and whomever wants to answer them, just tell me. And I'm really sorry. It's really hard to tell, right, the differences between specialities and how much each does. So there's a question here about AI algorithms being used to prevent fires. There is one, I'm understanding that this goes for you, but just in case, especially those caused by DC arcs through poor contact.
That's right, yeah. So we've incorporated a new feature in our latest inverters called AFCI, and this function can be enabled on the inverters. And once it's incorporated, within a matter of 2 seconds, the inverters can switch off the DC arc circuit. And the best option to have that is basically on the normal case, this wouldn't typically happen. The fire would spread quite rapidly. So there is regulations such as the UL 1699B standard, which is normally not incorporated into, let's say, projects within the Middle East at the moment. But this is something that I do see being quite frequently available in the future tenders that will become available.
Okay. To Jad and to Leandro, I invite you to take a look at the questions and see if there is anyone that you want to answer. We have a few minutes, okay? So just let me know. But first, I want to ask the question of cybersecurity. Should we be worried? What should we do, as developers of PV projects, when we are looking at these really advanced technologies, are we in more risk? And if so, how do we avoid it? So whomever wants to take this question, I'll just leave it up there for you guys.
I think it would be good to hear from Leonardo, from his perspective on Yoledor, on how they feel on that regards. And then I can happy to give some insight from the larger utility scale perspective.
We cannot hear you.
Glenn.
Oh, there we go.
Glenn, yeah. Can you please repeat the question? I was answering to one, so I
Sure.
lost
Yeah. No, I was just asking, like, in terms of cybersecurity. Can you hear me? Can you guys hear me?
Yeah, we can hear you, Leandro.
Okay.
Yes,
sorry, there was a bit of a crosswire there. In terms of cybersecurity, with these like advanced technologies where we're adding like technology complexity really to our PV projects, how do we save or prepare, to save ourselves, our projects from potential cybersecurity threats? What do we need to do? What technologies are there, and how much more vulnerable are we when we look into these kind of technologies?
That is really important, and taking the subject raised by Rizwan, we are more and more we are penetrating more and more in the grid, and the impact of disconnection of the solar, of renewable energy power plant is more and is higher and higher. So any malware that can enter in the PV plant and control the system, disconnecting the system, for example, or making some malfunctions on the system, can put at risk the entire grid. So there are a lot of firewalls, a lot of systems in place to take care about these securities, and of course this is a key point to pay more and more attention. Now I would say we are now contributing a lot to the grid, and the impact of our power plants are massive, mainly on the utility scale, of course.
Thank you very much, Leandro. I don't know if you want to add anything, Rizwan, on that, and then I'm going to ask Jad to choose one of the questions, and answer it. So go ahead, Rizwan, if you want to add something.
I think if anybody wants to touch base on it, please do contact me on that perspective. I do have more information on it, but due to time limitations, I'll hand it over to Jad, and let's get another question answered.
Yes. Okay, go ahead, Jad. There was a few here, but choose the one that you think is best. No, we cannot hear you at the moment. Your microphone's in mute? Now, yes.
I answered quite a few questions on the...
I saw by text, yeah.
Yeah. And there was a question about this technology, what do you use to get all this data onto a SCADA? So basically, Huawei have a smart logger, which that information goes from the inverter to the smart logger. That information gets pushed to a third-party device or to Huawei's platform, and which is how, so a smart logger is required with the inverter to get that information to the SCADA.
Excellent. Well, thank you very much to the three of you. This is totally one of those webinars where it's nerd alert. The people who attend are usually very knowledgeable about these issues, and you guys as well. And I'm in the middle here trying to catch up, but it's very complicated. Thank you very much for sharing your know-how. There are people here in the chat, I don't know if you've seen, that says, oh, thank you very much. I was looking for this type of webinar, very informative. So Thank you, Jad, very, very much for being here today. Thank you, Leandro, very, very much for being here today. And thank you, Rizwan, as well. As I said to everyone, we have the recording, we have the materials, we will send them to you. Feel free to get in touch with our speakers. You know, this is what we're here to do, because they are the people who are actually expert leaders in this sort of technology. So if you want to get the lowdown, you need to be working with them. So get in touch with them, get in touch with Jad, with Leandro, and with Rizwan for anything that you need, okay? If you need an introduction, we're happy to make it. So thank you very much, guys, and see you next time. Bye.
Very much. Bye.